Hello viewers, in our class today we'll be looking at the relationship between linear expansivity and volume expansivity. Let's first of all write the formula for finding linear expansivity and volume expansivity. This will serve as our guide in driving the relationship between linear expansivity and volume expansivity. V is the final volume. And what's the formula for finding volume? Volume is equal to length times breadth times height. So here will be final length times final breadth times final height. L2 is equivalent to this. So we are going to have L1 brackets 1 plus alpha delta theta. In the same way, this is equivalent to B2 brackets 1 plus alpha delta theta. And here will be H1 brackets 1 plus alpha delta, brackets 1 plus alpha delta theta. If we collect like terms, we are going to have L1, B1, H1, brackets 1 plus alpha delta theta, brackets 1 plus alpha delta theta, brackets 1 plus alpha delta theta. So let's take it in steps. Let's first of all take care of these two. We'll bring down this L1, B1, H1. This will multiply this and we say 1 times 1 is 1 plus 1 times alpha delta theta is equal to alpha delta theta. We now come over to here. Alpha delta theta times 1 is equal to alpha delta theta. Alpha delta theta times alpha delta theta is equal to alpha square times delta theta square. We bring down this again, we'll have 1 plus alpha delta theta. I hope you're following. We bring down this L1, B1, H1, bracket 1 plus, these are two like terms, so we collect them. So here will be 2 alpha delta theta plus alpha square plus alpha square delta theta square. We bring down this 1 plus alpha delta theta. Okay, we now take this to multiply this. So we are going to have L1, B1, H1, brackets 1 times 1 is 1. 1 times alpha delta theta will have plus alpha delta theta. We now go over to this. 2 times alpha delta theta. 2 times alpha delta theta times 1 will be plus 2 alpha delta theta. 2 times alpha delta theta times alpha delta theta will be plus 2 alpha square and delta theta square. We now go over to this. Alpha square delta theta square times 1 will give us alpha square delta theta square plus alpha square delta theta square times alpha delta theta will have alpha cube delta theta cube. Okay, at this point we'll collect like terms. If we do so, we are going to have L1, B1, H1, bracket 1. This will plus this, we'll have 3 alpha delta theta. Alpha square will be insignificant because the value for linear expansivity is a very small, and when it's being squared, it is extremely small. So this tends to 0. In the same way, this tends to 0. And as well, this tends to 0. So we are going to have L1, B1, H1 brackets 1, 3 alpha delta theta. V2, V1 brackets 1 plus gamma delta theta. Let's compare the two. These two are equivalent. This is equivalent to this. Of course, 1 is equivalent to 1. Change in temperature is equivalent to change in temperature. Therefore, we only have 3 alpha and gamma. What it simply means is that volume expansivity is equal to 3 times linear expansivity. In any case, where we are given the value for linear expansivity and we need to find volume expansivity, what we just need to do is to multiply linear expansivity by 3. If you find this class interesting, don't forget to drop a comment. Bye.